Hello, welcome to my channel. Today, I am going to show you how to create a Visual Studio SSIS package that imports data from Excel file to an Oracle database server. First, let's create an Excel file called sample_data.xlsx. The data set will have 4 columns which are name, age, weight, and birthday. Oops, I spelled the birthday incorrectly. Birthday. Anyway, that is okay. Later, I will show you how to change the data column headers when importing the data. We will quickly populate the Excel spreadsheet with 4 records also. You can see that the name column has a string data type, the age column is integer, the weight column holds a decimal data type, and the birthday column holds a date-time data type. Let's save the Excel file, then close and exit from the Excel. Now, let's use the Oracle SQL developer to create a database table that can hold the Excel data from which we want to import our data. Here, I have already copied and pasted the create table SQL statement. It will create a table called sample dataset which also has 4 columns, name, age, weight, and birthday. Let's run the create table query. Now, the table has been created, and we can also run a select statement. However, the table is empty currently. As you can see, soon, we will use SSIS package to import data to this Oracle database table. Now, let's open Visual Studio 2019 and create a new project. Select the Integration Services project as our project type. Just a plain Integration Services, neither the Azure-enabled Integration Services project, nor using the wizard to create or project. Click Next. Give our project a name, say, Import Excel, and pick a folder location where this new SSIS project will be saved to. For this demo, I will just save it on my desktop folder. We will also check the checkbox that says, place solution and project in the same directory. Yes, it's okay to put them all together. Then click Create. Before we start building the SSIS package, let's also move the Excel into this project folder. Import Excel. Now, drag a data flow task to the control flow pane. Right-click this new data flow task and select Edit to open it. Then, under the Other Sources section, drag an Excel source into the new data flow task. Right-click the new Excel source, click Edit to open the Excel source editor. We need to add or create an Excel connection manager for this Excel source. Click New to pick an Excel file and create the needed connection manager. So, we browse to our project folder and pick the sample data.xlsx as our data source. In the Excel version drop-down menu, pick Microsoft Excel 2007 to 2010. Then click OK to close the Excel Connection Manager dialog box. We now are in the Excel Source Editor dialog box. We need to specify the name of the Excel sheet that holds the data table. However, as you see, the name of the Excel sheet is not available to us. So, what is going on here? This is because the Excel source is only supporting the older version of Excel format, the .xls format. And our Excel file format is in the new version, which is .xlsx format. Therefore, in order to make the connection manager to work, we need to open our Excel file and save it as an older version, the 97 to 2003 version. So, let's fix this problem now. I will save the .xls version with a name as sample data version 97 to 2003.xls. Now, close the .xls version of the Excel file and go back to Visual Studio. We need to edit the Excel Connection Manager. Right-click it and select Edit to open it. Then, change the file path to the sample data version 97 to 2003.xls, the Excel file we just reformatted. The Excel version box is now showing Microsoft Excel 97 to 2003, which is correct. So, click OK to close the Excel Connection Manage dialog box. Right-click Excel Source, click Edit to open the editor. Now we can select Sheet $1 from the name of the Excel sheet drop-down menu. Yes, I know, our data sheet is named Sheet 1, but the Excel source editor appends a $sign after all of the sheet names. Also, click Preview to see our data in the Excel file. It is a way to verify the connection is working. Click Columns to double-check whether everything is all right. As you can see, the birthday columns will be imported as the birthday column still, and that is fine for now. Later I will show you how to use column mapping to fix it. If everything looks good, click OK to close the Excel Source Editor dialog box. Now, we are still inside the Data Flow task pane. We need a data destination. Under the Other Destinations, drag an ADO.NET destination task into the Data Flow pane. Drag the blue arrow under the Excel source task to connect it with the ADO.NET destination. Right-click at the Connection Manager's pane and create a new ADO.NET Connection Manager to connect to the Oracle Database Server. Click New, then change the provider to Oracle Client Data Provider. Enter your server name, login user credential, and password. Click Test Connection, and it works. Click OK and OK again to finish the configuration of the ADO.NET Connection Manager to Oracle. Now right-click, then Edit to open the ADO.NET Destination Editor. The Connection Manager has been automatically selected because we only have one ADO.NET Connection Manager that fits. If you have multiple ones, you need to pick the right one. Now we encounter another problem. The User Table or View drop-down menu is blank, is not populated for us to select a table. But no worry, we can enter the table name by ourselves, which is the sample_dataset, the Oracle table we create in the very beginning if you still remember. Let's manually type in the table name. Click Preview to show our empty table in the Oracle Database Server. Close the preview window, click the mapping, adjust the size and position, and manually map the birthday column to the birthday column. Then we are all set with the unmatched naming column problem. Now, we get a small, yellow-colored triangle warning sign in the ADO.NET destination. It complains about the data truncation issue. I think the default import size for string from Excel is 255, but in our Oracle table, the name column is only set to be 20 characters. Therefore, the ADO.NET destination is warning us about this data length truncation issue. But I think this will be okay, because we know the actual data is not 255 characters long. If you're worried, you can modify your Oracle table to allow a bigger string size. We can just run the SSIS package, and it will be all right. As you see, while we are talking, I executed the data flow task, and it finished importing data to Oracle without any problem. Let's run it again, and check the database again. We got 4 more records imported to the Oracle table. Let me rename this data flow task into data flow task for Excel 97 to 2003 format, because I am going to show you another Excel source provided by ZappySys, with which you can import data directly from the newer version of Excel files, aka the .xlsx files. You can install the trial version of the ZappySys SSIS Powerpack for local testing. The trial version is free and basically has no expiration date. The link to the ZappySys SSIS Powerpack is provided below this video. Let me disable this data flow task. Right-click it and select Disable. So, the new data records will not be imported through this task anymore. Drag and drop a new data flow task into the Control Flow pane and rename it as Data Flow Task for Excel newer version. Right-click it, then select Edit to open the Data Flow Task Editor. Under the Common section, drag and drop a ZS Excel source into this data flow task. Right-click this new Excel source and select Edit to open. And you can see this Excel source editor interface is different from the previous one. Click New to create a new Excel connection manager. A new connection is needed to connect to newer version of the Excel file. Therefore, on the path or pattern box, we will browse to our project folder and select the sample data.xlsx, the newer version of the Excel file. Click Test Connection, and it works. Click OK to close it, and the new Excel Connection Manager is named Excel 1. In the Select Table box, select Sheet 1, which holds our dataset. Click Preview to see the data in the Excel. Close the preview window, then click Columns. We can see that the name column data length is default to 255 characters, but we only allow it to be 20 characters. Therefore, let's change the length of the field to 20. Click OK to close the Excel source editor. The small yellowed color triangle icon warns us that we need a data destination. Therefore, let's drag and drop an ADO.NET destination to the data flow task pane. The configuration for this ADO.NET destination will be the same as the previous one, since we already have an ADO.NET connection manager created previously. We can use it in this new ADO.NET destination editor. Therefore, enter the Oracle table name sample dataset manually. Click Preview. There are 8 records from the previous importation. Close the preview window. Click Mapping. Again, manually map the birthday column to the birthday column in the Oracle table. Basically, we are all set, although the small yellow-colored triangle warning icon is still there. Open and close the Excel source to remove the warning sign. Save the package and run the package. See how it goes. The task ran successfully. Let's visit the Oracle table to verify it. Execute the select statement again, and we got more data records. Go back to the Visual Studio and stop the SSIS package. Execute the package again and check the database again, and we got even more records. So far, I have showed you the faster way to import Excel data to Oracle database. However, there is still a slower way I would like to show you. While this will be a slow way to do import data, however, for the sake of tutorial, it gives you the chance to put your fingers on each record, especially when you want to do some data manipulation or transformation before the data gets inserted into the Oracle database. While we were talking, I renamed the ZappySys Excel Connection Manager from Excel 1 to ZappySys Excel. You can always change any task or manager's name from the name field under its properties. Okay, yeah, let's disable the previous data flow task for Excel newer version 2 and move it to the corner. We will create yet another data flow task that would utilize a few variables. They called them the package level variables. So, drag and drop a new data flow task into the control flow pane and name it as data flow task. Put Excel into a variable. Open the variable editor icon at the upper right corner. Click Add Variable icon, give it the name O_dataset, select Object for its data type. We also need 4 more package variables, 1 for each data column. Therefore, click Add Variable icon again. Name the second variable as v_name. Its data type will be string. Add the third variable, named v_age, integer 32 data type. This is going to be a problem, and I will show you how to fix the problem. Add the fourth variable, named v_weight, data type single. This will have problem too, but anyway, add the fifth variable, named v_birthday, and data type should be date time. Clear up its default value, which is today. But anyway, it will set another default value for the date time data type. So, we can leave it alone. We have our 5 variables created that we need. Thus, we can close the package variable editor window. Yeah, we can also double-click the data flow task to open the data flow pane. Pretend that we did not have the ZappySys SSIS Powerpack installed. So, we will drag and drop the original Excel source into the data flow pane. Right-click it and select Edit to open the Excel source editor. Again, select the sheet $1 from the name of the Excel sheet drop-down menu. Click Preview to see the Excel data. For records, click Columns. This time let's fix the column header spelling on the output column list. Change the birthday to birthday. That is easy. Click OK to close the Excel source editor. We need a destination, but this time, we will drag and drop the record set destination into the data flow pane. Drag the blue arrow under the Excel source and connect it with the record set destination. Right-click the record set destination, select Edit to open its advanced editor. Interestingly, it doesn't look advanced to me at all. On the variable name field, we should select user::o_dataset as the variable to hold the Excel data. Click the Input Columns tab. We see that the birthday is spelled correctly as birthday. It is because that we fixed the problem in the Excel source step already. Therefore, we can simply click the OK to close the Advanced Editor for Record Set Destination. Click the Control Flow tab that next to the Data Flow tab. We find ourselves back to the Control Flow pane. So far so good. Now, drag and drop a ForEach Loop container to the Control Flow pane. We will use it to process the Excel data stored in the O_dataset variable one by one, record by record. First, let's drag and connect the green-colored arrow under the data flow task. I also rename the container name. Add, for each data row, to the name and make it clear to the viewer what this step is doing. Okay. Now, adjust the container size. Make it a little bigger, and drag and drop a execute SQL task into the ForEach Loop container. Then label the execute SQL task as insert record. Therefore, this process is very clear. we will execute an insert record SQL statement for each data row in the ForEach Loop container. Right-click the ForEach Loop container, then select Edit to configure the container. Click Collection, then select for each ADO enumerator as the enumerator. Set the ADO object source variable equal to user::o_dataset. Also select the rows in the first table. Anyway, we only have one table in the Excel dataset. Click the variable mappings. Now we need to use a series of sequential index numbers, starting 0, to map with the column variables that we created previously. The index 0 should be user::v_name. Index 1 should be user::v_age. Index 2 is user::v_weight. And index number 3 should be user::v_birthday. Click OK to close the ForEach Loop editor. This is a big task. I hope you can still follow me. Now, right-click the Execute SQL task, select Edit to open the editor. In the General tab, set the connection type to ADO.NET, and the connection should be the Oracle ADO.NET Connection Manager that we created previously. Now, click Parameter Mapping. We need to add new parameter map to each user variable, then use the parameters in the Insert Record SQL statement, which we will compose soon. Therefore, the first one is mapped to the user::v_name. Data type is string, and the new parameter name, we can label it as in_name. The parameter size should be 20. The second parameter is mapped to user::v_age, and the data type is integer 32, and the new parameter name can be labeled as in_age. The parameter size equals 5 is long enough. The third parameter is mapped to user::v_weight, and the data type is double, and the new parameter name can be labeled as in_weight. The parameter size equals 10 is long enough. The fourth parameter is mapped to user::v_birthday, and the data type is date, and the new parameter name can be labeled as in_birthday. The parameter size equals 10 is good enough. Now, let's click and jump back to the General tab to add our SQL insert statement. In the SQL statement box, click the 3 tiny dots at the right-hand side of the box to open the Enter SQL Statement dialog box. Since the box is so tiny, I put the insert statement in a text editor so that you can see the SQL statement clearly. The 4 newly created parameters are used in the statement, and also pay attention to that a colon has been prefixed to each parameter name. I mentioned that you can do data manipulation or transformation previously, and here is where you can put your fingers on each data record. For demo's sake, I am not going to mess up the SQL statement. Let's paste this SQL code into the Enter SQL Statement dialog box. Now, let us try to execute this SSIS package. Unfortunately, the execution failed. When we read the error message, it complains that the data type is not matched for the v_age, a double has been assigned to an integer 32 type, and the v_weight. A double has been assigned into a single data type. So, let's try to fix these issues. Open the package user variable editor. We will change the v_age to an object data type. An object type can hold anything no matter it is an integer or a double. And also, we will change the v_weight to be a double data type. Excel number seems to be read as a double data type. After the adjustment, the execution ran well. We can double-check the data in the Oracle server. Yes, the data are imported correctly. We can run the package again, and it went well. More data records show up in the Oracle table. Today, I've showcased 3 ways to import data from an Excel file. Each has its pros and cons based on your project's needs and budget. ZappySys is feature-rich but could be pricey, and you may also like to consider data transformation requirements before insert into Oracle. Choose the method that fits your scenario best. Enjoy the video, and if you have questions or suggestions, drop a comment below. If time allows, more content is on the way. Don't forget to subscribe and hit the like button if this was helpful. Thank you for watching.